Hello, welcome to my channel. In this video, I will talk about how to manage secrets in Oracle Cloud using our approach of the file secret managers and inject the secrets in Kubernetes. Also using environment variables as secrets to injecting applications using running inside your Kubernetes cluster. With the secrets will be encrypted inside the Oracle Cloud Vault and consumed by the applications. Now you can use any application. I will use a Micronaut application where we have a little bit more flexibility where we can consume the secrets. But you can use a Spring Boot application or any Java application or other technology you can use to consume environment variables or files as secrets. That doesn't matter. Kubernetes and Oracle Cloud are secret. They are agnostic about the technology you're using. First, let me talk a little bit about the application. The application has the concept of profiles using Micronaut. So I have an application default profile where the configurations for all the application is done, and I have a concept of overriding some of the configurations using profiles. So when I bootstrap the application, I set up the profile using Kubernetes, K8s, and the environment as well. Since you can have multiple profiles enabled at the same time, and this will change some configurations like the topics that the application is consuming in Kafka, like the ports for the application manager and Kafka producers and so on. So these are the configurations that I use to configure Kafka, and the secret for Kafka will come as configuration for in another or inside the Oracle Cloud application. So what we'll see here in that the Oracle Cloud application, you can search for Vault, and here you have the key manager Vault, and you can search for secrets as well. So let me show you what the vault is. The vault is where your secrets will be there. So if you come in the vault, I have a vault creation. It uses master encryption keys. You can search for the documentation in the Oracle Cloud and how to configure that. And inside the vault, I have the secrets manager. And here we have the secrets. Now, my application consumes one secret that is the application is called the Mercado, and I configure secrets for our environments. I add the environment as a slug as a prefix, as a su suffix of a prefix suffix for the application. So Mercado API config sit is the environment, and here I have created many versions for the application. You can enable application configure version as the default version, and you can you can roll back versions, or you can create a secret version. I like to view the context of the new secret, show as a plain text, copy the secret, and after copying the secret, I like to create a new secret version and pass it here. Or I like to edit the secret in the file for a context or a more highlight context, so it can help me in the edit of the secret. So because this is a YAML file, it has a syntax to follow. And I after I edit the secrets, you can I copy back another secret here. Let's check what is the current version of the secret. So I will not show all the secret, but I will show some configurations that I have done, like alter the context part and enable cores and added the cores here. The cores for each environment is a different URL, so I added this cores use, and I added security mechanisms for the client secret as well. So this is a configuration done from Micronaut. Now, the interesting part is how we connect the secret here in the identity cloud with the Kubernetes secret. Let's check in the Argo CD. The Argo CD application, we see that we have here external secret called app-config external secret. This is a manifestation for a project called external secret. External secrets, Kubernetes. This is the URL. Go to the latest version. So the external secrets operator is operator you can install in Kubernetes, and it has providers for various environments. So you can get secrets from IBM Secrets, from HashiCorp Vault, is a very OVM cloud in the Oracle Vault. So you can have secrets from many places here, and you can centralize the secrets inside the Kubernetes. So you fetch from external and get the secrets internally on your Kubernetes. So you have to install this operator. Once you have installed the operator, you have to provide a way that the operator to connect. The way I done it's through a policy. You can go here in identity security. Price, let's check its identity, policies, and they have a policy secret access, and I have some statements. So I allow a dynamic group that this dynamic group, it's one group that for each that recognize the machines that are a part of a Kubernetes cluster, and it allows these machines to use in the compartment that I created to use the target key.id, to use the secret, to use keys inside this vault, and to use secrets inside this vault as well, and to use secret families. So always use, not created, cannot modify secrets, can only check the usage of the secrets. So I will add the policies in the description of the video for you to have a reference. And this dynamic group, so I can search for the name of the oke-node-cluster, is a dynamic group. So we have machine rules here. And here I add all instances in the compartment that has a tag that call oke-node pool tags and the node pool variable name. Because when you create a node pool in Kubernetes, so let's, for completeness, let's check the node pool in Kubernetes. You add a node pool name, and the OKL Oracle Cloud will add a tag with the node name, with the node instances in the Kubernetes cluster. So I have a cluster here, and you create a cluster pool, a node pool, and the node name will be automatically added as a node, as a tag to the machine. So I can reference this tag and know that this node pool is inside my Kubernetes cluster. This is the way I create the dynamic group. So the dynamic group is connected to the policy, and the policy allow these machines to access the secrets. So this will allow every pod inside the Kubernetes clusters to access the secrets. This is not a good thing if you are a security person working in a large organization. If you use enhanced Kubernetes cluster, which is a paid version of the Kubernetes master node, the free version you don't pay for the master, you pay only for the worker nodes. And this is what I'm using here. Doesn't have this uh, capabilities I will talk about. I will talk with you. You could use a way of authentication only the pod, and you can reference only the access count of the external secret operator, and only external secret operator will have access to their secret. You can create policies reference that. Yeah, but this is advanced resource of their Kubernetes cluster. You can check the Kubernetes cluster documentation of the Oracle Cloud on how to do that. So connecting the Kubernetes with the external secret operator. This is an example of how to create a provider, and this is an example of how to create a secret. Let me check. Kind of secret. Repository data reply customization. Kind of secret. Actually, I can show you where is my external secret. Here's the external secret that I have. So you provide an external secret kind, metadata, we provide a refresh interval, the secret is stored, where is the configuration for the connecting with the secrets, a target for the secret. So my secret is called Mercado API config, which will create the secret inside Kubernetes. Let's check that this external secret, it creates a Mercado API config secret, and it provides the secret config with the key using the environment that I deploying the application. So the external secret will create the secret inside Kubernetes. Now, how do you connect the file with the secret? In my deployment, I add then the container. The container has micronaut config files, referenced a file that then I will mount the secret as a file inside the container. So I reference this as a micronaut config file. Each technology will have a way of doing that. They reference the file as a config file. And then I'm using a volume mount app config, mount secret store, and the mount secret store reference the secret. So it's a little bit complex, but this is the way done. But I will resume to you. We create the secret inside. We allow the external secret operator to access the secrets inside Oracle Cloud, and we in the Oracle Cloud we add the secrets as we add the secrets in Oracle Cloud. We create an external secret manifest inside Kubernetes. These external secrets fetch the secrets and adds as a secret inside Kubernetes. And then we reference the secrets as a file inside the container of the Kubernetes. And we have a refresh interval, so the external secret will be keep updating the secrets in the interval we add for them. The advantage of this is that external secrets can be a rub for secrets in multiple providers. You see that it's have the pressure for multiple providers, and you decouple your secrets from Kubernetes. You don't have to put the secret cryptographed here inside the deployment, which will be a dev CI/CD. You can use a CI/CD pipeline to encrypt your secret here, but I prefer to add the secret externally in a system external. And since we have this capability inside Oracle Cloud and I are hosted in Oracle Cloud, I'm using the external secret for Oracle Cloud. Maybe you can use the same approach for you pushing from the other provider like AWS Access, AWS Secret Manager. You can use the same approach and tell you. Um, yeah, that's it. Um, the way the way you do for an environment is that in Kubernetes you can add the secret as environment variables as well. So you are adding as a file, but because of volume amount, but you can check the secret as an environment from secret. So you can add something like this, every from secret half, and you add the secret path like this, secret name, API config, and then you have all the secrets as environment variables, but then your secret will have to be in the properties file approach. So my secret will you have key equals value inside your secret file, so you can mount as environment variables. And that's it. Thank you for watching. Have a nice day. Please take a like if you like this video and subscribe if you want. Thank you.